So this is part 2 of my series of talks on Boscovich's theory. It's about Boscovich's atomism. So I'm carrying on from part 2 and going by this book called Roger Boscovich, Forerunner of Modern Physical Theories by H.V. Gill. Atomism is the idea that matter is made out of particles. Modern physics is built on the idea of Boscovich's atomism, but that is usually omitted from physics students' education. So this is according to Gill. He says the primary elements of Boscovich are indivisible, non-extended, and are never in contact. And goes on, the primary elements of matter are, in my opinion, perfectly indivisible and non-extended points. They are so scattered in an immense vacuum that every two of them are separated from one another by a definite interval. This interval can be indefinitely increased or diminished, but can never vanish altogether without penetration of the points themselves. For I do not admit as possible any immediate contact between them. So compenetration is explained at the bottom there. And so continuing what Boscovich says, I consider that it's certainly that if the distance between 2 points of matter should become absolutely nothing, then the very same indivisible point of space, according to the usual idea of it, must be occupied by both together, and we have true compenetration in every way. Therefore, I do not admit the idea of a vacuum interspersed amongst matter, but I do consider that matter is interspersed in a vacuum and floats in it. So my note on that: vacuum exists, at least in the idealized situation of absolute nothingness. Whether or not such a thing can be physically achieved in any experiment, talking about in terms of matter interspersed in vacuum, but not vacuum interspersed between matter, I think not helpful, and just playing with words. But what we were talking about here really is point particles in a vacuum, and there's no vacuum inside the point particle. And Gill goes on, these points are possessed of inertia in the Newtonian sense, so that unless disturbed by the force exerted by another point, they remain at rest or in a state of uniform motion. Acting between these points, there is a mutual force which depends on and varies with the distance according to a certain general law common to them all. The important element in the theory of Boscovich is the nature of the law of forces between 2 points. He does not pretend to explain the reason and origin of this law of force, but is satisfied to take it as a fact. Gill quotes Boscovich and he says, this propensity is the origin of what we call the force of inertia. Whether this is dependent on an arbitrary law or the supreme architect, or on the nature of points itself, or in some attribute of them, whatever it may be, I do not seek to know. Even if I did wish to do so, I see no hope of finding the answer, and I truly think that this also applies to the law of forces. Gill carries on, it would seem that such a theory implies action at a distance. Boscovich, however, denies this. Before beyond the reason just given, which appears to be a confession of ignorance, he does not advance any scientific proof that his theory does not involve action at a distance. He admits that his theory is open to this objection. He evidently considers action at a distance impossible and simply accepts the fact that his theory does not involve it as something which cannot be understood. So my comment on that is Boscovich explains particles interacting through a sphere of influence around them, which would nowadays call a physical field. So what was meant was Boscovich replaces the idea of action at a distance by the idea of action through physical fields. And really that's a bit of playing with words again, because you could say action at a distance is action through the physical fields. However, going by Newton, Gill points out, now although Newton believes that no one who in philosophical matters has a competent faculty of thinking can ever fall into such an absurdity as to admit the possibility of action at a distance, yet such philosophers as John Mill and Balfour saw no difficulty in admitting the action of a body directly on another distant from it to be, as much as any other property is inherent and essential to matter, or found the comprehension of it facilitated in the slightest degree by the supposition of an ether. Nevertheless, the universal conviction of present-day physicists is that of Newton. So there were people, this is my comment, there were people happy with the idea of action at a distance. Newton, however, was unhappy with the idea. So when Gill says the universal conviction of present-day physicists is that of Newton, does he then mean they were unhappy with action at a distance, same as Newton, or they were just going to accept action at a distance? Gill carries on, clearly the whole physics of Boscovich was hostile to the idea of a medium, as shown in his views on the nature of light, in which he denies the wave theory in any form. And my comment on that by Hall of Physics means the physicists of when Gill was writing, which was in the 1940s, really need more clarification that is lacking on this as well, as regards Boscovich's theory with its points particles influence each other through the physical fields. I consider that as acting like a medium when the disturbance travels through a collection of those particles. So in my view, that would be acting like a medium and might as well call a medium. There's no need to deny a wave theory for light in the context of Boscovich's theory. Of course, we've got a problem now with the words again. It's thus unfortunate that I can't fully agree with how Gill is representing Boscovich's theory. I will, however, be pointing out some of the interesting things Gill says. Pointing out again what Gill said earlier, it would obviously be going too far to expect a theory put forward 200 years ago could apply to the niceties of recent scientific thought, but it is claimed that in many cases the fundamental principles underlying modern physical theory are to be found in the ideas first proposed by Boscovich. So my comments on that is a bit of thinking is involved in how Boscovich's theory fits with modern physics, where modern physics as such concepts as wave-particle duality that were not around in Boscovich's day. So Gill says this: it is right that we should remind ourselves that our modern way of looking at things involves quite as many mysteries as does the theory of Boscovich. So my comment on that is, and it's probably because the foundation of physics, which is modern physics, this very mysterious atomism, that the education establishment wants to mention it as much as possible, or you gloss over it, because their aim is to try to make the subject they teach easier for the students, hence they dumb things down for them. It would not help to start teaching a physics course and point out in the foundation of physics is point particles, and it's all very mysterious, because then the students might start protesting, and you don't want that. You don't want arguing at the first lesson, and so they want to gloss over talking about point particles properly and jump straight on to other things. Thank you, that's the end of this little talk.